Okay, so this is a pattern. Okay, so we can see at the moment is a pattern is a significant part of maths is discovery analysis of patterns in various situations. Once the pattern has been identified, the next step is to use the pattern to predict the future or to correct the past. This is usually done by describing the pattern in the following terms and stages of the pattern. Okay, so what we have here is question 3. Okay, and we said a design is made from purple and green squares. Okay, copy and complete the following table. Well, what we can see from the following table is that the number of green squares in the first one is 3, basically 3 all the way across. The number of green tiles never changes. The number of purple squares goes 1, 4, 9, 16. What we can see is 1, 4, 9, 16 are squares. 1 squared, 2 squared, 3 squared, 4 squared. So basically the next one's going to be 25 and the one after that's going to be 36, because look, they're all squares at the end of the day. Okay, now total number of squares is going to be 4, 7, 12, 19, then we're going to have 28, and then 19, 28 and 39. Okay, so that's the total number of squares from each one. So what it's saying next is derive the formula for the number of purple squares. Okay, well, when n equals 1, the total of purple squares is 1. When n equals 2, it's 4. When n equals 3, it's 9. The gist is, okay, so the number of purple squares is basically n squared. It's the term, whichever term it is, squared. So in the last number there's 36 purple squares. Okay, now every single time we square this we have to add on 3, because this 3 here is a constant. That's for the total number of squares. Okay, so that's going to be n squared plus 3. Hence, otherwise calculate the total number of squares being used in the 18th pattern. Well, in the 18th pattern it's going to be 18 squared, because it's going to be 18 across, 18 up, and that's going to be plus 3. And 18 squared plus 3 will give us 327. Okay, moving on to question 5. A pattern of buildings consists of a number of doors, okay, and windows. How many doors will there be on the 5th building? Well, we can see that the number of doors goes 1, 2, 3, 4, so there's going to be 5 doors on the 5th one. How many windows will there be on the nth building? So what we can see here is there's 1 on the first one, 4, 9, 16. So we can see that it's going up in squares again. So it's going to be 5 squared for 25 for the next one, 6 squared, and on the nth building there should be n squared. Okay, so it should be n squared buildings, okay, or n squared windows. Now, if each door and each window needs a security lock, how many locks are needed for the nth building? Well, in the nth building there's going to be n doors, because if this is n, it should have n amount of doors, and then it will have n squared amount of windows, so it's going to be n plus n squared. Okay, and that's the end of the first exercise.